Hey guys, I wanted to make a quick video to show you how to do this conservation of momentum part 1 momentum. Some people get confused by the pictures on it, but it's really quite simple. You don't even need a calculator to do it. So let me take you through just a couple examples here. So I'll start the attempt. And it says we have a stationary bomb that explodes. So the whole idea here in all of these is that momentum is conserved. That is, if there's no outside forces on our system, which just means our collection of objects, then the momentum of that system can't change. So since it's stationary, you can see right here that it has no momentum beforehand. That means afterwards, the system can have no momentum. It can't change. So the first question says, what is the total momentum of the system after the explosion? And the symbol we use for that is P prime, momentum prime, or the momentum afterwards. So what's the total momentum of the system after the explosion? Well, the same as it was before, so it's 0. And so let's click on to the next one. So that would go in this little blank right here, the momentum of the system afterwards. Well, then it says, what is the momentum of object 2 after the collision? The symbol for that would be P prime 2, the momentum of object 2 afterwards. Well, let's look at this. If the total momentum of the system's got to be 0, look at piece 1 afterwards here. It's got a momentum of -10. The negative just means to the left. But we still got to get to a total of 0. So how do we get to 0? Well, to cancel out this -10, then the momentum of object 2 afterwards has to be just +10. But for this whole worksheet, don't put the positives. You'll see it sometimes in the pictures. Just put nothing there if it's positive. If it's negative, put the negative. If it's positive, just leave it blank. It's too hard for me to tell it on every question to grade it both with the positive and without it. There's too many different options there. So anyway, so we'll click next there. I'm actually going to skip ahead a little bit here, show you another example sort of like that. Let's go all the way up to number 8 here I clicked on. So this one's very similar, except now it starts out with a moving bomb explodes. So this bomb's already moving. And you can see here that the momentum of the system is 10 kilogram meters per second. But I'll just not say all that. I'll just say 10. So the first question says, what is the total momentum of the system afterwards, P prime? Well, remember, it can't change. It's conserved. So if it was 10 before, it's got to be 10 afterwards. That's P prime, what would go right here. So once again, they tell us P1 prime, the momentum of object 1 afterwards. So what's the momentum of object 2 got to be? That's going to be our next question. So if this is -10, but we got to get all the way up to the system for 10, then what's this one got to be? What plus -10 will give you +10? That means the momentum of object 2's got to be 20, right? Because if this was 20 and we added it to -10, then we would get a total of +10. So that would keep the momentum the same. So that's what you'll do there. So that's the whole thing here, is you got to think about the momentum stays the same the whole time. So for example, on this one, they sort of switch it up. They tell you the momentum of this object, 2 pieces of clay stuck here together, is 4, +4 afterwards. That means it had to be +4 before. And that is how pretty much all of these work. Even if you come back to like number 3 here, it says object 1 is coming in here with 10 units of momentum. Object 2 is just sitting there. So what's the momentum of the system? Well, the momentum of the system here in question 3 would be the momentum of object 1 plus object 2. They say that right here. So it would be 10 plus 0. So the total momentum then would be just 10. And then we know that no momentum is conserved. It would stay the same afterwards. The last thing I want to show you, even though it gives you a mention here, is the very last one sort of switches. You're going to have to find the momentum. And so just remember that momentum is mass times velocity. So find the momentum of the child and find the momentum of the wagon. That starts on number 17. All the other ones, they just straight up tell you what the momentum is. So it should be pretty easy. Give those a try and then message me if you have any questions.